Let's consider problems using the ordered pair representation. Which of these are functions? And if not, why? Let's look at problem A. The first thing to remember when writing a function as a set of ordered pairs is the first element in the pair is always the element from the domain. In this relation, we see that 2 is mapped to 2, 3 is mapped to 4, 4 is mapped to 6, and 5 is mapped to 8. There are no repetitions in the elements of the domain in the pairs. Thus, every element is mapped to a unique element in the codomain. This is a valid function. In problem B, we see that the element 1 of the domain is mapped to both 2 and 4. This means that not all elements in the domain is mapped to a unique element in the codomain. If you wish, you can try to view this using the graphical mapping between sets that we did earlier, if it helps. Note the non-unique elements 1 is mapped to. Thus, this is not a function. Problem C is a slightly less common textbook problem, where textbook problems tend to involve numbers. The domain here is a set containing animals, specifically a bird, a cat, and a butterfly. Nevertheless, this is, as a matter of fact, a valid function as each element in the domain has a unique image. Let's revisit the problems A and B using the graph representation. If we draw a vertical line through the graph here, we could see that the vertical line intersects with the graph at 2 points. This simply means that the element 1 of the domain is mapped to 2 different elements in the codomain. Hence, it's not a function. But if we draw vertical lines through the graph of problem A, anywhere on the graph, the vertical lines intersect with the graph at 1 point only. This means that every element in the domain would be assigned to unique elements in the codomain. Therefore, it's a function. This technique of identifying if a graph represents a function or otherwise is called the vertical line test. We shall have a look at the next question in the next tutorial.